Betelgeuse, an unmistakable red supergiant star situated around 650 light-years away in the Orion constellation, has captivated astronomers due to its dramatic behavior and potential for a spectacular supernova explosion. Sitting on the left shoulder of Orion, Betelgeuse is one of the brightest stars in the night sky, although its brightness fluctuates significantly over time. These variations have sparked intense interest among researchers, especially after a notable dimming event that raised the possibility of an imminent supernova. While it is evident that Betelgeuse is nearing the end of its life, the exact timing of its final explosive event remains uncertain. Betelgeuse is considered relatively young by stellar standards, with an estimated age of around 10 million years, compared to the Sun's 4.6 billion years. However, due to its massive size, the star has rapidly exhausted its hydrogen fuel and is now in the late stages of stellar evolution. It has expanded significantly, entering the red supergiant phase, during which it is fusing helium into heavier elements like carbon and oxygen. This stage is much shorter than a main sequence star's lifetime and indicates that Betelgeuse is on the path toward a supernova. When it ultimately explodes, the event will be a cosmic spectacle, potentially visible during daylight hours and rivaling the brightness of the full moon. The journey to a supernova for a star like Betelgeuse is complex, involving several layers of nuclear fusion as it transitions from lighter elements like hydrogen to progressively heavier ones. After the star exhausts its helium, it will begin fusing heavier elements, such as carbon, neon, and magnesium, in a process that continues as it approaches the final stages of its life. Eventually, the buildup of iron in the core becomes the tipping point, as iron fusion is energetically challenging. When the star can no longer sustain fusion, the core collapses under its own gravity, resulting in a core collapse supernova that can outshine entire galaxies for a brief period. Betelgeuse's behavior has become particularly intriguing in recent years due to significant variations in its brightness. Typically, the star follows a predictable cycle of brightening and dimming over about 400 days, with its magnitude fluctuating between 0.3 and 0.8. However, a dramatic dimming event occurred in December 2019 when Betelgeuse's brightness dropped by nearly half, reaching the lowest level ever recorded for the star. This unprecedented dimming sparked speculation that a supernova might be imminent. However, the star's behavior eventually returned to a more typical state. Researchers have since attributed the dimming to a combination of factors, including a massive dust cloud formed from material ejected by Betelgeuse and changes in the star's surface temperature. The cause of the extraordinary dimming appears to be multifaceted. Observations suggest that a substantial amount of gas was expelled from Betelgeuse, which then cooled and formed a dust cloud that obscured part of the star's light from reaching Earth. This process is entirely normal for red supergiants, which often shed their outer layers as they near the end of their life cycle. The dimming event also coincided with a temporary drop in the star's temperature, indicating that complex processes were at play in its outer atmosphere. These changes are significant because they provide insights into the star's evolving state and the dynamic processes that precede a supernova. Another factor contributing to Betelgeuse's erratic behavior is the presence of massive convective cells on its surface. These convective cells are responsible for transporting heat from the star's core to its outer atmosphere, leading to uneven surface temperatures and significant fluctuations in brightness. The size of these cells is enormous, often spanning a substantial portion of the star's diameter. As the star continues to age, these convective processes may become more pronounced, potentially leading to more dramatic changes in its appearance. The star size is also a factor in its variability. Betelgeuse is massive, with a diameter estimated to be over 1,000 times that of the Sun. If placed at the center of our solar system, its outer surface would extend beyond the orbit of Jupiter. Its size makes it particularly prone to instability, as the outer layers are not as tightly bound by gravity as they are in smaller stars. This allows material to be more easily ejected into space, forming dust clouds that can temporarily dim the star's light. The scientific community is divided regarding the timeline for Betelgeuse's potential supernova. Some researchers believe the star could be in the final stages of its carbon-burning phase, meaning a supernova could occur within the next few decades or centuries. Others argue that Betelgeuse may still have thousands, if not tens of thousands, of years left before it reaches the point of core collapse. For example, astronomers from Tohoku University in Japan have suggested that Betelgeuse is in the late stages of its stellar evolution, while researchers from Hungary's Konkoly Observatory maintain that the star could still be in an earlier evolutionary stage where helium fusion dominates. Astrophysicists from Harvard have also suggested that Betelgeuse may be 100,000 years away from a supernova as it continues fusing helium at its core. When Betelgeuse ultimately goes supernova, the explosion will have a dramatic yet not dangerous impact on Earth. Given the star's distance, the energy from the blast will not be harmful to life. However, the event will generate an influx of high-energy particles and electromagnetic radiation, which could potentially affect Earth's atmosphere and lead to temporary disturbances in the ozone layer. This could result in minor increases in ultraviolet radiation reaching the surface, but our planet's atmosphere and magnetic field will protect us from the most harmful effects. Astronomers will gain valuable scientific insights from observing a nearby supernova. With Betelgeuse so close to Earth, it presents a rare opportunity to study a star's death in unprecedented detail. The star is large enough to be resolved by telescopes, such as the Hubble Space Telescope and ground-based observatories using adaptive optics, which can provide detailed images of its surface. Observations of a supernova explosion in real time could also improve our understanding of the mechanisms driving such events and the formation of heavy elements throughout history. Supernovae have been observed and recorded by various cultures, often appearing as bright, temporary stars in the night sky. The most famous historical example is the Crab Nebula, which is the remnant of a supernova recorded by Chinese and possibly Native American astronomers in 1054. More recently, the supernova observed by Johannes Kepler in 1604 was visible during the daytime for several weeks. These historical records highlight the cultural and scientific significance of observing a supernova, and Betelgeuse's proximity makes it a prime candidate for the next visible supernova in our Milky Way galaxy. Comparing Betelgeuse to other massive stars further emphasizes its uniqueness. While there are other red supergiants nearing the end of their life, like VY Canis Majoris, their greater distance from Earth means that their potential explosions wouldn't be as visually spectacular as Betelgeuse's. Furthermore, Betelgeuse's rapid evolution, due to its mass and proximity, makes it an ideal target for